Ladies and gents, welcome back to another Engineers podcast. Today I'm joined by Daan, who's the VP of Engineering at an organization called Source.ag, and we're going to learn a little bit more about the lovely world of AI. Again, this is a bit of a theme, but essentially, Source.ag are doing some pretty cool stuff enabling greenhouse growers to produce more fruit and veg using AI, and we're going to get into how they actually do that. So, Dan, nice to meet you. How are you?
Nice to meet you too. Thank you. I'm doing fine. I'm doing great.
Good, good. For the listeners, do you want to give us a bit of a background into Dan and your career?
Yes, for sure. So I've been working in engineering for about 13 years now. I'm 42, so before that, he joined the engineering
Late
profession,
bloomer.
so to say. Yeah, so I worked as a musician before that. So I studied piano, jazz piano, and worked in all kinds of bands and played in a lot of venues in the Netherlands and outside of that. But when I was about like 28, 29, I decided, no, this is not the career I want to grow old with, so to say. And I switched to software engineering. So been working as a software engineer since about 2010. And first doing regular engineering stuff, building web applications, building backend systems, some front ends. At some point, pivoted more into data engineering. And in the last 5 years before I joined Source, I worked more on sort of the edge of engineering and leadership. I did this at KLM, Royal Dutch Airlines, where I worked as a director of engineering and architecture for a department that used AI to build tools to help people in the KLM operation make better decisions. And this is, I would say, a recurring theme in the which I continue at Source, so to say.
Yeah, we're going to explore that. We're going to explore that. Before we do, can we find you online playing any piano?
Yes, you can. So not by myself, but there is a band on Spotify for which I wrote music, or rather a singer on Spotify for which I wrote music, and I play piano and various other keyboard related instruments on that. But probably to your listeners, it wouldn't be super interesting because it's in Dutch. Although I guess you also have Dutch listeners. So if you want to check it out, she's called Renee van Bavel, and she's an amazing singer. So
All right.
do check that
Okay.
out.
That'll be in the below. Um, and tell us about the cross train into software engineering, how that happened, why that happened, because something I didn't know I want to explore.
You mean me transitioning from music
Yeah.
to software engineering?
Yeah.
Yeah, sure. So maybe a little bit of background about me. I've been interested in computers all my life, and I've actually been programming since I was about 12, 13 years old. So my dad had an Atari ST computer. These are not made anymore. But I programmed in BASIC various like small applications, like an address book for my dad and that kind of stuff. Um, but I also had a keen interest in music. Both of my parents are musicians, and so at some point I decided this is going to be my career. I'm going to do music. So I went to the conservatory, studied, got a diploma, joined bands, like I said, and played music for quite a while. I would say I've not been super successful in the sense that I got rich off of it, but I could make a decent living.
Okay.
But what I really missed was this intellectual challenge, basically. I liked puzzling, and this is something that I did not do as a musician that much. And so there came this moment in my career as a musician that internet was like getting big. We're talking about like mid 2000s, and I felt like, okay, as a like if I want to take myself seriously as a musician, I need to have a website. But you can probably imagine musicians get paid like shit. So I did not have any money to hire someone to build a website. So what do? You just teach yourself how to build a website. So
Yeah.
I got into PHP, even got a bit into design, and built my first website as basically my personal brand as a musician.
Good for
And
you.
that this was so much fun that at some point I thought this is making me happier than touring around the country, being like getting up at 12 at noon because you go to bed at like 6
Yeah.
a.m. And so
That's what it's all
basically I
about.
switched around. So I switched it sort of around. I thought, you know what, music can be my hobby, and I still
Yeah.
practice piano a lot, but like engineering it, that this can be my profession.
Good for you. That's what it's all about. Tell us about Source AG and share with us subscribers just who you are as a business and what you do.
Yeah. So Source.ag was founded by Rien Kamman and Ernst van Brugge, two guys that met in Delft at the university. And I know Rien from working together with him when I was working at KLM, and he was working at the Boston Consulting Group. And Rien and Ernst set out to figure out what kind of business can they start that leverages AI, which both of them have experience in before, but then for something that is better than as a consultant building solutions for airlines or oil companies or these kind of things.
Yeah.
So they built Source, and I was the first employee that they hired actually. So that's I've been here from the beginning. And what we're trying to do at Source is we want to empower fruit and vegetable growers to feed the world in a climate resilient and resource efficient way.
Okay.
So without breaking planetary boundaries. And we want to do this because we see that a large portion of the human population does not have access to sufficient fruit and vegetables. So they don't have access to a healthy diet, as it were.
Yeah.
And this is, of course, a problem with economic aspects to it. Maybe they don't have enough money to buy it, but it's also definitely a supply problem. Especially with climate change, there's less and less areas in the world where you can actually grow fruit and vegetables. So we felt how can we contribute to a solution to improve the supply of fruit and vegetables. And the way we want to do this, the way we all want to empower growers, is by giving them the world's best AI software to help them start, run, and or expand their farming business. So in terms of market, we're really focusing on controlled environment agriculture, which basically means, in our case, greenhouses, high-tech greenhouses, and more also mid-tech and low-tech greenhouses.
Okay. Where you can without betraying the confidence of the business, are you able to break down the AI in the business and what it actually does?
Yeah, sure. Maybe to give a bit of, let me give you a bit of a product overview, as it were.
Yeah.
To build proper AI, we first realized we need to gather a lot of data. And this is also something where we felt with this data, we can already help the grower get insights in how they're running their business. You have to imagine a grower, they have to plan a whole season ahead. So they have to know for the whole year, what am I going to do? When am I going to, I don't know, prune the plant, the fruits? What temperature am I going to make it in the greenhouse? They make a strategic plan for this. They call this a crop plan. And the first thing we built is we connected to all these sensors in the greenhouses to show them, hey, you have this strategy set out for the year. Are you actually meeting it? Are you actually achieving your strategy by comparing what they put in their strategy to what we measure and the business metrics we built on top of that? So this is the first part of a product. And then AI comes into the mix because then we say, hey, wouldn't it be cool if you can actually help the grower make a better strategy? So, and this starts by saying we can predict, based on AI, we can predict with all this data, if you change your strategy in a certain way, what will be the outcome? Will you have more or less harvest? How will your plants grow, basically? This is done for a large part through simulating the plants. So we are simulating the biological behavior of these plants. This is also interesting from, I would say, from an employee perspective, because we not only work with engineers and data scientists, we also have plant scientists that work for us to figure out how do these plants behave. So that's the first part of the AI product. And then the second part is, okay, cool, we've gotten a better strategy for them. How can they execute on this? Because you also need to know exactly when during the moment, what moment during the day will you um, irrigate your plants? How much will you irrigate them? So the last part of a product that we build is called Control, and we basically figure out what irrigation strategy we should give the grower on a daily basis, and how to execute that by literally controlling the greenhouse through the climate computer from a software.
Okay. The one thing that I think is really interesting that you touch on in there, and now you say it, I can see an evolution more towards this with the introduction of more AI, and it's something you wanted to speak about. But the team makeup inside your remit as a VP of engineering, you obviously have engineering, software
Yeah.
engineering. You obviously
Hmm.
have the AI arm, which I can imagine encompasses plant scientists, I believe, and other people.
Hmm.
So, what does that relationship look like? What challenges does that present?
Yeah, excellent question. So this is an interesting relationship that we've been trying to figure out at Source for the past 3 years. And I'd like to think that we've gotten pretty good at it, but it's by no means something that automatically goes well. So, like you said, we have indeed an engineering department, which is led by me. And I have a colleague called Cedric, and he is the VP of Data and Plant Science, and he runs, let's say, the science department. So there's a whole bunch of data scientists there and some plant scientists. I think his team is like 20 people in size, and my team is like 30 in size, so pretty equal. And from the get go, we decided we think it works best if we put data scientists and engineers and even plant scientists to some extent together in a multifunctional team. And the reason we did that is because I think it all comes down to you build it, you run it. So I know that there's some companies who say, you know what, we'll just let the data scientists develop a model somewhere. And at some point, they just throw it over the fence. And then engineers will look at it and think, we need to productionize this model. So sometimes they will even completely rewrite it and then put it into production. And when something goes wrong with the model, I guess it's up to the engineers to fix it then. So we don't want that. Basically, we want those data scientists to feel empowered, but also responsible to fix their own code when something goes wrong in production. This is not easy, to be honest, because mm, data scientists and engineers have different focus areas. I would say, even like in the way they're educated and in the experience that they bring, data scientists are very much concerned with the math, the statistics, the data, the algorithms, and they want to get a job done, but they don't necessarily out of the box care about things like, is it well tested, is the code well structured, is it robust, how is the error handling going, these kind of things. But if your code is going to end up in production, you damn well make sure that you care about those things, right?
Yeah.
So this is an interesting learning for the data scientists, but also for the engineers, because they suddenly get like an extra task. You're not only going to build stuff, you're going to help your data scientists in your team to think about these things like testing and code structure.
Yeah, I can really see how it presents a new set of challenges now because you will have a focus, of course, on software engineering, but AI being a primary focus and part of the product offering that you're providing, that's centered around the models that you're building. So one is equally important to one another,
Absolutely.
but you really do have to think about the AI being the cell behind the product in essence.
Absolutely. It's good that you mentioned this, how central the AI is to the product, because it is different than, let's say, building a recommendation engine where you can offline build a map of recommendations for your users. That is where we're in production, we just read some recommendations from a database, right? In our case, it's really the AI is on the critical path, so to say, of the user experience. these users, they will type in their, for example, their strategy into our products. They will, like, you can imagine it's sort of an Excel sheet where they put numbers week by week, what they want to achieve. And then this input is used in real time to tell them what the outcome of the strategy is. So this model is run continuously throughout the user using the product. So if the model is something is not correct in the model, it will break down and production will break down. It's not like this batch job you can rerun again and be fine.
What becomes challenging between the two different ways of working, methodologies, and I guess the skill sets that these people have? Like, what becomes challenging when pairing the two together?
Uh, I would say it comes down to priorities. So, like as a data scientist, you're mostly concerned with research, getting the best numbers out of your model, getting the best statistics, so to say. Um, and you want to go above and beyond, like, to get these numbers. And when it comes down to it, you might not really care whether the rest of the code surrounding your model is well tested or anything. um, and at the same time, these engineers, they feel the pressure of this thing that you built might break down in production, and will get called out of bed for this. um, so when do you stop improving the model to make it the absolute best and start focusing on the robustness so it can run safely in production? This trade-off, these priorities, I would say, are a constant source of good discussion within our company. In the beginning, what we did is we put the data scientists and the engineers together, working on the same product from the start. And this sometimes also led to a lack of focus, because these data scientists, they did not know, do I now need to focus on improving the model, or should I focus on bringing this to production? So, but we also didn't want to fully separate these two. So we've arrived now at a situation where we say there is a separate team with data scientists. They build, let's say, the next version of the model. But when that's done, we sort of rotate these data scientists into the productization team, as we call it,
Yeah.
and they will work in tandem with the software engineers to bring their model to production, their new version of the model to production. So they get to experience productionizing that code, learning how to make it robust, and they'll bring that knowledge back into the research team when they go back there. So
Okay, interesting. And from a technical perspective, how has your AI impacted greenhouse growers?
mm, I would say, first and foremost, it gave them a lot more certainty around their operation,
Mhm.
if that makes sense.
Yeah.
So as a grower, you don't know what's going to happen with the weather on a day-to-day basis. It always amazes me with the technical advancements in our society, how bad we're still at weather prediction. So this is like a huge source of uncertainty for the grower, and they do not have to make a couple of decisions each day. They have to make tens or hundreds of different decisions each day with different outcomes. And the worst part of it for the grower is a lot of these decisions will only have visible downstream effects, let's say 4 weeks from now. So you irrigate the plant in the wrong way, and you might not even notice it tomorrow or the day after, but 4 weeks from now, you will have basically messed up your production, and you will have like 10% less harvestable fruits, for example. So these decisions are hard. So we give them the certainty. The AI gives them the certainty by
Yeah.
being able to see what the impact of these decisions is going to be.
Okay.
Does that make sense?
It definitely does make sense. You mentioned you've also got a short-term algorithm and a long-term algorithm. Can we talk about these two?
This is something I mentioned in the beginning of the conversation, where the long-term algorithm is really about, you have to set a strategy as a grower for the whole season, which usually takes like lasts a year or so. and you have to decide now. It's like, let's say it's November, and you have to decide now what you want the temperature in the greenhouse to be in April. You can imagine this is a pretty daunting task. So this and this growing strategy, this crop strategy, our long-term algorithm helps you simulate what the effects on the plant will be for given your strategy that you give it as an input. And you can adjust your strategy and then see the different outcomes, and you can compare them. And down the line, we can even improve this by saying, not only can we see the results of the changes you make to your strategy, we can actually suggest better changes to your strategy ourselves using this AI. This is like the long-term algorithm. Then the short term is, given the strategy, okay, I know that today it needs to be 21 degrees in the greenhouse. I know a weather prediction. When do I open the windows?
Yeah.
At what temperature do I set the heating pipes? Or
Wow.
what I mentioned before, when do I irrigate the plant, and how much, and how much nutrients do I put into the irrigation mix? This is the sort of short-term algorithm. And this short-term algorithm will literally control the greenhouse. So we are interfacing with the climate computers, which is uh, both exciting and daunting, because
Yeah.
we can make a huge impact positively or negatively on how the greenhouse operates there. So
And what data are you actually collecting from the sensors, the greenhouse itself? It'd be really good to gauge that because you've built, from what I understand, some pretty smart algorithms. So it'd be
yeah,
great to
thanks.
understand where they've been sourced from, in essence.
Yeah, it's a great question. Especially, I would say data is the most important asset
Yeah.
we have. And so we started out by collecting a lot of data, sensor data from the greenhouses itself. You have to imagine most of these greenhouses, they have something called a climate computer, and this climate computer both gets input from sensors but also controls the greenhouse. So we hook into these climate computers, and we get all of the sensor data. This is mostly on like a 1 minute to 5 minute frequency, where we get new updates from these sensors.
Yeah.
This is climate data, irrigation data, a bit of resource usage, like how much energy are you outputting through your heating pipes.
Yeah.
This is one part of it. Pretty early on, we also discovered, if we want to be able to optimize this strategy of the greenhouse, and in essence, we want to control how the plants grow, we also need to know, like we need to observe how these plants grow.
Yeah.
And the growers were already taking, in some shape or form, plant measurements. Most growers do this, but they were doing it in quite an old-fashioned way. Often they would put numbers in Excel, or even they would walk around with a notepad physically, and it would write down numbers and then later on add them into an app. And this was not super fine-grained. We felt if we want to really simulate the biology of the plant, we have to also have fine-grained observations of the plant. So in order to facilitate this, we built our own iPad app. So we give each grower an iPad with an app which has what we call the digital twin of the plant. It's literally a visual representation of what the plant looks like, be it a pepper plant or a tomato plant or a cucumber plant. This is what we currently support. And what you do as a grower, every week, one or more times, you walk through the greenhouse, you have a bunch of sample plants, let's say 20 or so. And for each plant, you will mark in the app what are the changes that I'm seeing. So a certain fruit might have a different color than it had last week, and you will mark this in the app. And based on this, we build up this digital representation of how the plant evolves over time. And as you can imagine, this is a great input for the algorithms to simulate these plants over time.
Yeah.
So this is, I would say, the maybe the most important sort of data that we generate and
Okay.
use.
I think that's pretty interesting. In fact, I do think
Yeah, it
that's pretty
is.
interesting. It'd be great to understand how you are actually collecting this data from a technology perspective. I know serverless architectures are actually involved in this, but also it'd be great to try and understand the whole technology sphere and how you're actually doing this.
Yeah, it's a good topic to discuss. So you mentioned serverless already. When we want to collect the sensor data from these greenhouses, we have to connect to these climate computers. And as
Yeah.
I mentioned, we want to get updates at least every 5 minutes. Preferably, we want to get real time updates, like when a sensor value changes, we want to get it. But this is not always something that a climate computer API offers, basically. So, what we do, we have a setup that is comprised of a bunch of serverless functions. We run this in AWS Lambda. And some of these lambdas, they will basically poll the climate computer APIs every 5 minutes or every minute or every 15 minutes, depending on the climate computer brand. And it will get the raw data from the sensors at that moment in time, basically. This data is stored in S3 buckets. um,
Yeah.
it's always a smart choice to keep your raw data, because downstream in your transformations you might make a mistake, have a bug, and it's very nice to be able to replay the raw data through your data pipelines and
Yeah.
sort of retransform the output. And based on the data arriving as three, basically we have a bunch of lambdas that are triggered by this, which transform the data and, let's say, turn it into a unified model, data model that is the same across all climate computer brands.
Yeah.
This data is then stored in the time series database. We use Timescale for this. It's an
Yeah.
extension based on Postgres, which is very nicely suited to having time series data and being able to aggregate over that for our downstream consumers.
Awesome. I do actually want to explore a little bit about your growth
Mhm.
because I know you've mentioned that you've grown the business massively over the last 12, 18 months or so. It'd be
Mhm.
good to understand the growth coming into the next 12 months. And this is an opportunity to do a little shout out to our audience who are listening, who will no doubt be engaged in what you guys and girls are building, but who you're hiring for, what you're hiring for over the coming 12 months from what you know right now.
Yeah, yeah. I guess that is a good caveat. We don't know for sure what 12 months from now looks like, but we've tried to make a plan. And so maybe to first look backwards a bit, we've grown in the past 3 years from like the two founders and then me, and up to like 100 people right now. So it's pretty massive. 50 of those are data scientists and engineers, product people like product managers and product analysts, and a customer support, customer operations department, of course, your regular finance
Yeah.
people, legal, etc. We've also recently started growing our commercial team, and I would say this is maybe not super interesting to your audience, but I want to put it out there. We're looking for great salespeople because we want to sell these amazing products, obviously. But at the same time, we're also growing our engineering team still. And what we're looking for, we made a conscious choice not to diversify too much in the kind of roles we have. So at Source, we only have, I would say, two flavors of software engineer. We have the, let's say, more back-end focused software engineers, and we have front-end engineers.
Yeah.
And the engineers that we're currently hiring for are back-end engineers. And you'll be able to work on many different kinds of technologies. So we don't have dedicated data engineers. You'll be doing data engineering. You will be building APIs. You will be like designing databases. All that kind of stuff will come on your lap, fall on your lap when you work at Source. So I think what it boils down to is that we're looking for a bunch of very talented and curious software engineers who are not necessarily married to one single technology stack and are open to trying out all kinds of different things. And to whet your appetites a bit, we're using mostly Golang and Python and TypeScript. Mostly everything is running on AWS. Like I already mentioned, smatterings of serverless things, but also regular Dockerized ECS services. Yeah.
Love that. That was a really good overview of the stack and like holistically as in what people could expect. I think it's a fascinating journey over the last couple of years. Two founders, ex consultancy backgrounds. You've got a partnership and an understanding with them from your previous firm to come in and build something to the scale that you have, especially in the climate and sustainability space. That is a really hot space at the moment, and the products that you're offering, I think no doubt there's going to be people that are interested, throughout
I hope
Netherlands,
so.
and we do have a large Dutch presence. So, hopefully off the back of this, it does generate some interest and people are getting in touch with you, not just for your piano skills as well, by the way. Um, but we've wrapped this up in 30 minutes or so, and it was a real succinct, to the point product overview of what you guys and girls are building. And no doubt, I've got no doubts. There goes the lights. Um, no doubts over the next 12 months, I'm sure you will go and emulate the same success as what you guys have had in the last 12.
That's what I hope as well. Yeah. And I'm also pretty confident in the team that we can pull it off. So
Yeah, for sure. From what I've seen. So, Dan, a massive thank you for coming to join us at Engineers. If you're listening, likes, shares, subscribes, come and share your story with us. But share a little bit more about what the Source team are doing. And Dan, again, big thank you.
thanks for having me, Elliot. It was a blast.
Good. And bye for now, everyone. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no underscore. We've also got a website which is Enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.